Hello everyone. Let's see. Okay, let me share the invitation. The link, I mean. Hello everyone. Let's wait 2 more minutes before people gather. We'll see if they come or not. I am prepared regardless. Okay, let's start. Today's topic is design patterns, and we're actually starting chapter 6 of C Sharp Bootcamp. That is design patterns, and we'll try to understand how can we apply solid in practice, what problem are we actually solving, and how does it help in our daily software development routines? How is it applicable? Um, Yeah, so today we'll try to analyze the types of design patterns, strategy pattern, why we want it, why we need a command pattern, how are the two different. We'll revise solid principles, and we'll talk about other things as well. Functional programming, relation with object-oriented programming, with live coding examples. So today's problems. Why is writing software harder than writing a letter? Give yourself a minute to think about this. Writing a letter is quite cheap. You can toss it away if it's unsuccessful. You can even cross out words you don't like. And you pretty much see immediate result, and you will not come back to it after years to continue writing. You will start and finish If not today, then this week for sure. So that is letter. Short term, discardable, easy to fix, changes are easy. However, if you think about writing some piece of software, especially designing a system from scratch, a mistake, especially early on, a mistake in understanding what is actually needed from that system can basically mean that all the work that you're doing is for nothing. That your effort is vain, and that you are not really achieving anything with it. How would you feel if suddenly you had to discard such a system? Give me a second. How would you feel if you suddenly had to discard such a system that you were writing for even a month and you realize that you're doing something absolutely not needed by the client? The problem with this is that even if you do realize it, it is likely to be too late. And um, in case it's a massive change that needs to happen, it might mean that you're better off simply rewriting the whole system. And all of that is expensive. Mistakes in software are expensive. So the sooner you find them, the better. So software is much more like construction work rather than writing a letter. And we want our project to last long and last long through the changes. And for that, we need a good foundation. And good foundation for software is requirements, architecture, and design. And this applies not only to requirements or architecture, this applies throughout the whole levels of a product. Its requirements, system, module, class, and function. And why do we need all this? It's to maximize the work not done. We are lazy, we want work to be cheap, and the cheapest way to like the it's a paradox, but the cheapest software is high quality. Like if you want the software to last long, you need it to be high quality, because if it's low quality, it will break, and fixing it will cost much more, as opposed to having high quality product. It's a massive uh, paradox that often business fails to understand. So, if we talk about software as construction works, for structures, the biggest issue is earthquake. It breaks structures. It makes buildings collapse. And for software, earthquakes are casual changes. And those changes happen all the time. So basically, as software developers, we need to always take in account changes that will happen to software, and we need to design it that way that it will be change proof. Or rather, we're not avoiding changes, we're simply embracing them, and our architecture allows easy changes. And I love this quote. I found it on Twitter, and it says, "If you think good architecture is expensive, try bad architecture." It's brilliant. Good code is cheap long term compared to bad code. Talking about software design is a big paradox in itself, because often you won't understand if design is good until it becomes bad. Like you you can tell if design is bad if it breaks, if there are immediate issues or issues after time. But if it stays well, you cannot say it's good until it becomes bad. So it needs some time for software design to be proven to be good. and if it stays stable, and if it remains working as intended, then you can consider that software is good. So a good bridge is not a bridge that is built and stands today. A good bridge is good that stands after a century it's been built. So the same goes for software. It's very difficult to measure your design to understand if it's good or not. And therefore, we need to often rely on time-tested solutions. And those solutions are design patterns. Those solutions are best practices and fundamentals, the principles that we should follow when designing a system. Solid is a design for change. If change wasn't happening in software, if requirements weren't changing, then we could work with a waterfall strategy and just incrementally build our software without even considering a change. We could hard code things. They won't change, but they do change, and we need to account for that. So since design patterns are based on solid principles, they are what helps us, what aims to help us to make a change-proof system. So with design patterns, you can have a system that has solid roots. And there are a ton of design patterns, and we'll only be talking about roughly a third of them. But before that, let's talk about solid. Let's revise what is solid, because without knowing what solid is by heart, don't even try to go into design patterns because you won't understand them. So let's quickly revise each solid principle. Single responsibility principle says that a class should only do one thing. There is an alternative description which says a class should have a single reason to change. And my own description of it is to split stuff, but not too much. If you have a doubt if it should be split or not, usually it means it should be split. And follow logical rules. And as long as in real life it makes responsibility, like it makes sense what responsibility different things have, then that probably means that in design it will make sense as well. So example violations of single responsibility principle is when, let's say, a reader needs to be aware of a writer. That's a no-no. Or a book that locates itself. That's also a big no-no. Another one, so that's single responsibility principle. And it's often violated because it's convenient to put stuff in the same place and things expand, grow bigger, more and more unrelated things get added into the same place until it becomes really difficult to understand that single place. Divide and conquer works very well, and this is the remedy for violations of this principle. Open-close principle says that classes should be closed for modification but open for extension. And it means a very simple thing, that you should aim to write new code instead of changing existing code. Write code incrementally, because every new change you introduce into existing code is potentially a breaking change. An open-close principle just minimize those breaking changes. So don't hard code it, inject it instead. Open-close principle can be implemented through two ways usually. First one is a classical inheritance way, where you inherit and write new implementation there. Or it could be implemented, which is a better way, the new way, through composition, and injecting components that are responsible for that logic instead of implementing the logic yourself. Compose the logic rather than implement that logic. So now you'll have different components that are responsible for it, and those components will be responsible for one thing, and the higher level component will simply compose them. And you won't have to care about how it's managed. Liskow's substitution principle says that a parent should be replaced by a child in all cases. So for example, if you have, let's say, a car wreck and a car, this is not like this will be recorded, yes. You will watch it on YouTube, yes. So Liskow's substitution principle says that the parent class should be fully replaced by a child, and an example of it is if you have a car, you might say that car wreck is a child class of a car. Because it has a body, it has a wheel, it has windows, it has a steering wheel, and so on. But, I mean, can a car wreck move? Can you drive a car wreck? And if a fundamental thing of a car is to move, if it's to get you from one location to another, and car wreck cannot do that, is it still a car? It's a philosophical question, but it's more simple than that. If you do not satisfy a contract, and let's say a contract of a car is just to move to a location, then you're not a car anymore. And you shouldn't pretend to be one. That's why a car wreck should not inherit a car, because it isn't one. It's a wreck. The same goes for a toy soldier, for example. If a toy soldier is just a soldier that's made of clay, it has a gun, but it cannot shoot, it cannot talk, it cannot move, then it isn't really a soldier, it's just a toy. So Liskow's substitution principle simply means don't fake it. Call things what they are, implement the contract that you promised to implement, and do not fake it. And this is a great example on the right. If it quacks, if it looks like a duck, if it quacks like a duck, but needs batteries at the back, you probably have the wrong abstraction. Don't try to take batteries out of a rubber duck and put it into the butt of a real duck, because you might get an unexpected reaction. I've seen this in software, and I will keep on seeing this in software. Fortunately, the more I develop, the less I see it, but I see it nevertheless. Interface segregation principle says simply to don't force to depend on things that you don't have to. Those things being methods. So if you have, let's say, an interface with 3 methods and your implementation needs only 2 of them, then basically make the interface smaller. Compose it out of 2 methods. But don't force me to implement 3 methods when I only need 2. And ideally, I should only ever need 1, so that I never even have to choose what to implement. By choosing to implement an interface, I should always implement all that it asks me to. And basically, to say this in human language, keep the contract small. And if you keep it so small as 1 method on an interface, you cannot go wrong. It's very interesting because if we think a bit about functional programming, actually interface segregation principle is implemented by default in functional programming because a function is always just one. A delegate is a contract. A function is a single method that implements that delegate. So it's always ISP compliant, interface segregation principle compliant. So it's really good. Like with functional programming, you are solid compliant in most cases out of the box. With OP, you're not, but you can be, though it's a bit more difficult. Anyways, a practical example, imagine you need to put a plug in a hole and there are many choices. You don't know where to put it. You don't even know if you need all them. You don't even know if any of those are suitable. Yet you have all those choices. Yet you need only one. So interface segregation principle in this case would say that instead of that box with many plugs, I'd only like a single plug. And lastly, dependency inversion principle that says that high-level modules should not depend on low-level modules. Both should depend on abstractions. And the second part says that abstractions should depend on abstractions. And the second part is what people get horribly often wrong, horribly often, and actually even seniors more often than not get it wrong. We do not depend on third-party abstractions when we are not extending those abstractions. We are supposed to depend on our own abstractions. Otherwise, we are doing it slightly wrong. Unless we are working directly with those abstractions, we shouldn't depend on them. So an example violation would be, let's say there is a very popular library called Mediator that basically executes your commands for you. And we often inject it in controller, which is fine. But if we start injecting Mediator in, let's say, some business component that has business logic, that is hella bad, because it's infrastructure, it's third party, and it's not our own abstraction. Abstractions should depend on abstractions, our abstractions, standard abstractions, and not some other abstractions. So if we design an abstraction, we shouldn't expose a mediator or something like that through it. And ideally, if we are dealing with if we are dealing with third-party stuff, we should have a dedicated component for that and not mix it in. Exposing stuff through constructor is okay-ish for third-party stuff, but don't expose it as a public interface thing where you can interact with that third-party abstraction, because it's not your own thing. It's not an abstraction. It's a detail of infrastructure. That contract is a detail of infrastructure. So an example of dependency inversion principle is a power plant. And do we need to know that the electricity comes from a power plant if all we want is to turn on the lights? And the answer is no. We just turn on the lights. And this is a lot about what dependencies can we know about and what cannot. And in most cases, you can remove the burden and simply say that for 99% of cases, simply inject stuff. If it provides logic, don't hard code it, inject it. So for example, if a gun provides logic of how to shoot, a soldier should not create a new gun by itself. It should take a gun as a constructor parameter. It should be injected. If a commander commands a soldier, it shouldn't command the soldier. It should command a commandable um, object, something that is commandable. It could be a dog, even. It could be a soldier. It could be a civilian as well. Commander can command different things. So it shouldn't be just a soldier. Yet it is soldier out of those many things. We shouldn't be limited to just that. We should simply identify soldier as someone that can be commanded. So in that case, a soldier can be commanded, and also a commander is probably commandable as well. So interesting. And now let's move on to how it all comes down to design patterns. The types of design patterns. And now I'll just briefly run through all of design patterns that there are. The first category of design patterns is creational. Abstract factory, builder, dependency injection, factory method, object pool, prototype, singleton, structural. So creational patterns solve a problem of basically how do we create new objects. Always new objects, nothing more. Structural patterns solve a problem of how do we compose different components into a working system. How can we ease the communication between components? So we have adapter, bridge, composite, decorator, delegation, facade, flyweight, marker interface, and proxy patterns. And lastly, we have behavioral patterns. They solve a problem of how do we abstract away what we need to do? How do we simplify interaction with objects? And examples of such patterns are chain of responsibility, command, interpreter, iterator, mediator, memento, null object, observer, specification, state, strategy, template method, and visitor. And I won't talk about the next categories of patterns. I just want to show that there are different categories, not just those three. So concurrency patterns solve a very common problem of asynchronous concurrent programming. We won't talk about any of those in this chapter. I just want to show that there are a lot of patterns that you could have a look at. And definitely, you most likely won't need to implement any of them because frameworks already implement a lot of those. Architectural, actually, it's insane. There is even more patterns. And if you ask me what patterns I know out of those, I can quickly go through and I say I haven't even heard about ADR. I know active record. I know broker. I know client server. I don't know CBD. I know DAO. I don't know DTO. I know DDD. I don't know ECB. ECS, I don't know. EDA, I don't know. Front controller, I know. Identity map, I don't know. Interceptor, I don't know. Implicit invocation, I don't know. Inversion of control, I know. Microservices, I know. MVP, I know. MVVM, I know. Monolithic, I know. Publish, subscribe, I know. REST and SOA, I know. Service locator and specification, I know. So basically half of those I only know. And cloud distributed, I don't know any. Okay, I know some of them. So let me say which one which one of those I know. I know anti-corruption layer, CQRS. I have heard about pipes, gatekeeper, event sourcing, publisher subscriber. Sorry, I don't know about that. Sharding, I haven't touched, but I know that big MMORPGs like EVE Online, where there are like hundreds of thousands of players, they do that thing. WoW does sharding for sure. Strangler, I've heard about its microservices pattern. The rest, I don't know. Throttling, also something load balancer related, probably implements it. So yeah, like, and I would say as a software developer, for starters, you should really focus on those three categories. And this is what we will be focusing on: creational, structural, and behavioral patterns. Because that's the problems we as developers will be solving. Concurrency patterns are good, but that's low level stuff. And unless you program in C or C++ or other low level languages, you probably won't care because framework does that for you. So for us, we won't care about those, especially not in C sharp. Architectural, you will care about if you make your own projects, big projects, projects that like Bridge should stand for decades and centuries, but it's definitely not a priority for starters. So I would say when you have like 3+ years of experience, you can then focus on them. I'm not saying that you shouldn't focus on MVC or MVP or similar when you're working with a framework. Like when a framework is based on that pattern, then definitely learn it, understand it. But if you don't have to deal with it, you don't really have to learn it as a beginner. And cloud distributed patterns is really next level when you're working with microservices. And I would say after 5 years of experience, only then try starting looking into them, unless you're really into microservices. And this is the gang of four, the guys who basically created those design patterns. The first three categories, I mean, Ralph, Eric, Richard, and John. Just some dude asked, what are the most common architectural patterns? Are there any common ones? Let me quickly go back to the slides and think about it. Data access object, data transfer object, you use those all the freaking time. All the time. Always. So it's always there. Active record is an old one. You don't use it. Rarely. Oh, you will see active record in legacy systems. It's when basically object can save itself. Data access object is basically object that provides access to data. I mean, for a database that has a way of accessing, getting data from database. A repository would be an example of it. A data transfer object is just an object that's used for parsing stuff, for sending stuff. So responses, request objects, objects that you use for parsing JSON, XML, and so on. So you use those all the time. Controller, if I'm not sure if that's what it means, but front controller, maybe it means just a controller pattern. We use that all the time in Web API. We use that also in JavaFX, if you have worked with it, and similar. It's common. There is no WOMS pattern. And out of those, MVC is a very common one. MVVM is a very common one. And DDD is a very common one. The rest are not very common. At least from my experience. Obviously, REST is very common. An inversion of control, like you inject dependencies. All right. So now let's get into the two patterns of the day. We'll start small. Command versus strategy. Yeah, there certainly are many. Okay, command. What should be done? That's what command says. You basically execute a command and it does something. The whole point of command that it absolutely simplifies what you need to do in order to execute an action. You just execute it. You don't even need to pass anything in most cases. So a command is meant to do different things in the same way. Different things. Different commands represent different actions. Self-sufficient takes no input. Why would you need a command? Well, because you might want a unified execution. You want to simplify that complex execution of an action. Oh God, bots. Jesus Christ. How do I ban? Oh, I can ban. How do I hide? Jesus Christ. Let me ban. Sorry. Okay, done. Okay, so command is used to encapsulate an action, and it says what needs to be done, and we encapsulate an action in an object. The benefit is that if it needs a state, if let's say it needs something to interact with, we pass all of that through a um, constructor of command. Not through arguments when executing it, but through a constructor. So no matter what arguments we need, no matter how complex things are, they will always be executed in the same way. And example of implementation. So here you can see the like absolute dead simple classical command pattern. You basically just have an execute method and multiple implementations of how you execute a command. And an example implementation of command pattern for a specific problem could be a remote TV controller, where different commands um, have, well, where you basically have a one-liner for every command on a TV controller. Like every button on a TV remote controller will be a one-liner. And even if the implementation changes of that one-liner, it's still encapsulated in it. So it won't affect the remote controller itself. Other good examples of command pattern is, for example, an editor. You know, when you are in a notepad, let's say, when you type some words, some symbols, and then you delete it, and then you type it again, you can also undo or redo it. And that's basically done through saving those commands into an action. Basically, every button press, every movement is a command that you made. And a list of commands can represent a history of your actions. And if you uh, invert those actions, if you do the opposite of what they did, or if you play them back, you can basically replay and simulate, redo, and undo with that. So that's another application of command pattern. Though that would be also combined with memento pattern, about which we'll talk in the future lessons. And another thing is that if, let's say, you have a Pokemon that, let's say, upon attacking does multiple things, or upon dying has multiple actions, you could also say that you execute death command, and let's say it does a whole bunch of things like explodes, and then um, uh, mm, causes friendly Pokemons to grieve, and then causes enemy Pokemons to cheer, and so on. It could encapsulate many things. A command can be many different things. Strategist. For this one, I'll stop slightly and let you read this. And I think that for many of you, this might look familiar. Basically, there was a bug in Civilization 6 where Gandhi, basically, Gandhi, for those who don't know, is one of the symbols of peace. But there was a bug in Civilization 6 where instead of being the most peaceful, it became the most aggressive AI ever. And it was attacking, declaring war to everyone. So basically, from developer's point of view, I can say that maybe Gandhi had a different strategy, a mixed strategy for him. A strategy can be passive, it can be aggressive, it can be defensive, it can be friendly, and so on. And apparently, he was aggressive. So the strategy pattern can look from first sight exactly the same like command pattern, because you also have an interface and you also have a single method that implements that interface. But the difference here is the purpose of why we have strategy and why we have a command. We have a command for different things executed in the same way, and we have a strategy for the same things executed in the same way but simply implemented differently. So the outcome needs to match, the execution needs to match, but what happens under the hood varies. And example of this could be sorting algorithms. Like you could have sorting algorithms injected, bubble sort, merge sort, and they will sort differently. It's not very practical, of course, but at the same time, you could inject different AIs, passive AI, aggressive AI, and so on. So why would we need strategy? Well, we have polymorphic methods and we have complex behavior encapsulated into objects. All right. So another applications of strategy pattern would be pathfinding strategy, or as I mentioned already, AI. But for AI, it's not very true because probably AI will be implemented with state pattern. And state pattern is when very similar to strategy, but in that case, you would have multiple methods that represent different behaviors, but based on a state. About that later. So strategy and command, and now you know differences. Command for different actions done the same way, executed the same way. And strategy is for the same action implemented differently. Before ending the theory part, it's very important to mention that context is extremely important to understand. And it's much more important than the UML, than to simply know how a pattern looks like. It's useless to know how a pattern looks like if you don't understand the problem it solves. So don't try to memorize design patterns. Try to genuinely understand them and look for real life references, real life problems that they could solve. Understand those problems and actually try to solve those problems the way you think is correct. Argue and disagree if you think it is over engineering. Solve a problem in your way. And ideally, the end result will be that you will be stuck, or if you try to simulate a change in requirements, you will see that many places need to change for a change to be implemented. So when you stumble across those problems, when you hands down face them, only then try to practice design patterns and see how they actually solve problems. Actually, don't even look for design patterns, just try to apply the best practices naturally. And design patterns will come naturally at you. So nail design patterns before trying to apply them at work, because there is nothing worse than not being to justify your choices and parroting what someone said. Understand how things work and why they're useful and apply them. Then understand the alternatives. Be pragmatic as well. Simply, sometimes we don't have time, and if you won't be touching a system for a really long time, it's fine to go for a simple, dumb solution if you know for sure that you won't need to go back to it. But in most cases, you will. So you need to understand what you're doing and what for, and make the right choice. And in order to understand that, you need to be absolutely proficient and nail the patterns you want to use. So don't practice them at work by no means. Practice them in your personal projects. And before finishing this theory part, it's quite important to talk about software craftsmanship and this map. I'll take a drink and let you look at this map for a few minutes, so be right back. So I'm back, and I hope you had a good look at this map. And all I wanted to say from this map, that as a software developer, you will never be able to say, I know everything, or like I'm very good or the best. It's always a journey that has no end. But that doesn't mean that you should not even try to follow that journey. We fail, we rise, we improve. But the point of it is not be afraid of failing. And the point of this is to speak out. Let people know what you think about different things. Maybe your solution is actually better than theirs, and maybe your thoughts will lead to improving existing principles. Or maybe someone's thoughts will make a lot of sense to you and reshape your opinion. So speak up, be loud, be heard. Don't be afraid to say nonsense, because there's no nonsense if you can justify it. If you cannot justify something that you're doing, then it is nonsense. But if you do justify it, if you do follow it, and if someone denies it in a constructive way, then be happy. Be happy because that leads to learning. I would say that 2 years ago, this all was new to me, and just like you, I was learning, practicing, and struggling to understand what is a good way and what is not. But what I did in those 2 years, I tried really hard, talking, practicing, discussing it on a daily basis with people way smarter than me. And I'm not parroting them. I honestly talk and discuss and argue, not in a bad way, of course, in a constructive way, until it makes sense. Play devil's advocate for things that, you know, if they don't make sense to you, it's fine. It doesn't have to make sense to you, but please be so kind and talk and ask questions until it does make sense to you. Don't stop bothering people until it makes sense. That's the essence to learning. And if someone struggles explaining a topic to you, that doesn't mean that you're stupid for not being able to understand. That's a good indicator that the person that is explaining the topic might not be very proficient at that topic. If you know the topic very well, you should be able to explain it to anyone, even someone who doesn't even do software engineering, even to a 6-year-old. So keep that in mind. You're not stupid if you're not able to understand. Maybe someone is very bad at explaining. But that shouldn't prevent you from understanding the root cause and understanding what is the right way. So I'll read what Peter Thomas said, but before that, I would really appreciate, guys, if you could write one thing that you think you understood very well, and I would like you to share that with others, just your thoughts about this lesson. And one thing that maybe you're curious about and would like to ask a question, or would like to understand something better. So I'll type that in the chat. So please write those two things, and in the meanwhile, I'll read what's in the chat and try to comment on that. So Peter Thomas wrote that this makes me feel badly about learning from tutorials. Lol. Lots of parroting there, so I can understand how this stuff is implemented. Yeah, that's a big problem, and actually, in I would say half of those cases, you're not the only one parroting. The tutorial maker is parroting what they learned recently as well. That's the problem with tutorials that are not professional, because they are being taught by people who just got familiarized with the topic often. So they can be poorly thought and just replicates what someone else did. And then you wrote, granted, after I parrot, I deconstruct and optimize, but just watching classes on C# doesn't feel like enough. I can never fully understand how things work in real world application. I didn't either. And the only way to understand that is by getting a job in making real world applications and dealing with real world problems. If you're dealing with your personal problems, you won't get enough experience to witness what a real problem, what a big problem is. So it's really, really hard. It's really hard to realize that by yourself. That's one of the reasons why I said try to talk with people who are smarter than you, who are more experienced than you, whom you trust, and try to understand why things are needed or not. It's very important. So join a community, talk, discuss. It's important. That's why I built C Sharpen for that reason. And lastly, if guys saw how many static methods I had in my personal app, I doubt they would think my solution was better. Most of my logic and justification is it was the only way I knew how to make it work. Yes, and I did that too, and a lot of people did that too. But people change and it's fine. Like your initial solution that works that way and that doesn't break, it's fine if it fits the requirements and if you manage to solve a problem for the scope, let's say it was a personal problem, it's absolutely fine. You shouldn't apply enterprise architecture on personal projects unless your personal projects aim to beat enterprise. Different design suits for different solutions. And that's a difficulty that I myself struggle because there is no one answer for architecture or design. And as a programmer, you need to be pragmatic quite often and take tactical solutions, not perfect solutions. We're not being paid for delivering perfect code. We're being paid to deliver good enough code that fits the requirements. So even if you know what's the best way might not always be the right way to take. And Todorok said, what I understood, the need for learning the principles behind design patterns and not memorizing them. What I would like to understand better, under what scenario should we use strategy versus command? They seem to achieve very similar aim. Perhaps as coding example will help. Yes, coding example will help and I will demonstrate it soon. But to answer your question, as I said, a strategy is for doing the same thing. So you would not write a command for implementing sorting in different ways because sort, if it's bubble sort, if it's merge sort, if it's quick sort, if it's other kind of sort, it's still a sort. It does the same thing. It does it differently. If it does the same thing, but that thing is done differently, then it is a strategy. For example, imagine a chicken, though this is more a state pattern, never mind. Chicken is a bad example. Imagine pathfinding. There are different pathfinding algorithms, and imagine you were simulating one. Let's say take a move would be a strategy. How do you take a move given a maze, how maze looks like and where you are? There are different algorithms for that, so each algorithm would be a strategy how you find your way out of a labyrinth. And logically, do you command someone to find a way of labyrinth, or do you choose a strategy how to find the way out of a labyrinth? Do you command numbers to sort themselves, or do you apply a strategy to sort numbers? Well, obviously you apply a strategy to sort numbers, and there is a strategy for finding a way out. So even logically speaking, it wouldn't make sense if you are using commands for those. So different algorithms for the same thing are strategies. Now, command with a TV remote controller, I can press a button for shutdown and a certain thing will happen, like a remote controller will turn on or off. I mean, the TV will turn on or off. If I press 1, channel 1 will turn on. If I press 2, channel 2 will turn on, and so on. If I press plus next to volume, volume will increase by 1. If I press minus, volume will decrease by 1. And imagine each of those things are complex to implement. It's just not decrementing, incrementing stuff. It's more than that. So that is implemented through commands. Could be, because it's different actions. So you encapsulate a complex action into command and just execute it. I press a button, I execute action. I press another button, I execute another action. So yeah, different things executed the same way. How do I execute an action? I just call execute method, regardless if it's turn on, off, volume up or down. I will show in live coding example as well. Anyways, I'm very glad that this is the things that you understood, because that was my goal, to make you realize that you shouldn't try to memorize, you should try to understand. Okay, good. So let's move on to live coding part, and let's do some live coding. With design patterns, it's a very nice topic to try to model real-world scenarios and try to model them logically. How would it work in real life? So here we have a TV class. And a TV class has isOn method, channel, volume. Like, what's the current, like, obviously when you buy TV, by default it's off. The channel, when you turn it on, I don't know, what's the default one? Maybe 1. And volume, let's say it's at 50. Know that I set those internally, because imagine it's very complex. Like, you cannot set it from outside. You can only set it through a remote. And then we have a remote controller. And what does a remote controller control? Like, would it make sense for a TV to be constructed with a remote controller? Should a TV know about a remote controller? And the answer is no. And since a TV shouldn't know about remote controller, obviously TV remote controller needs to be aware of the TV that it controls. So we inject a TV. Inject means we pass it through a constructor. So this is the TV that we injected. And we create different commands for controlling a TV. And the key point here is that each command is always a one-liner, and each command is executed the same way, except this one, though this one is more an exception than the rule. So, if I raise a volume, I just execute the raise volume command. If I lower it, I do the same thing. If I do this, again, I do the same thing. And actually, there is one interesting thing. If I go to change volume command, and if I bring the command interface again, oh crap. Okay, can I have both of those? Yeah, I can. Whoops. So you see the UML, the diagram on the right. We have a command and command interface, and command interface simply has one method, execute. A simplified way of executing an action. And change volume command simply implements. What is a change volume command execution? It's simply incrementing a volume by some change. How do I apply a change? Well, I simply pass all that I need, the TV that I control with change volume command, and the change itself through arguments. When you are working with commands, you should never pass input through execution. Avoid that. Because the point of a command is that it's simply executed. The execution itself is simplified. And the most simple way of executing something is by simply saying execute. No arguments. 0 arguments. You cannot go more simple than that. So that's my change volume command. What I have right now is over engineering, but you should presume that this command has more code, not 1 line implementation, but 100 lines. And in those cases, it certainly makes sense. Because if each command had 500 lines of code, then we would have, if each command had 100 lines of code, then 5 commands would have 500 lines of code, which would make this class too big, and it would need to be split. It would need to be split because TV remote controller is a high-level concept, and we shouldn't really care about how specifically it controls a TV. It should just control it somehow. So the lower level concepts of how volume is raised, etc., is delegated to commands. I'll show change channel command. It's simply implementing iCommand with param. So through a generic parameter, this command basically accepts any generic t, but always the same one. So change channel command accepts a number, like what channel should it change? And it sets the channel of TV. So that's the TV, those are the commands. I could have injected those commands, but I honestly don't see much benefit. Because they won't change, they will probably internal. I don't really care about them. But I'll show you an interesting thing, very interesting thing. The testability part of it. So this is the TV remote controller. And if we go to the demo, what do? We create a TV. We create a TV remote controller that controls this TV. We turn on the TV. We change channel to 5. We raise volume by 1. And let's see the status of TV right now. Channel. And if we go here, let's comment that out and run. So you see we set the channel to 5, we turn the TV on, and we increase the volume by 1. So it works. if a command has many dependencies itself, more than a TV, then definitely inject them. Definitely. In my case, each command will only have a dependency from TV. So it makes sense to do something like this. But I mean, it's a very good question. Like, you look at this code and you manage to see a flaw in it. And that is true. It's truly a flaw if the requirements change that way. I added a disclaimer that I know that this won't change. So I don't need to have a super design to cover that. If it was to change, I would definitely inject it. They will always depend on just a TV. They can surely depend on more things, but in this case, we don't care. Because it won't. Okay, so there is that, and I'll now demonstrate a strategy. So actually, this is a really good example. How do you find the smallest number from a collection of elements? Like, what ways do you guys know of finding the smallest number in a collection? What would you do if I said you find the minimum number? Or minimum anything? What would you do? I'm really curious. Because you can do what? Min will only find minimum number of the two, but I'm talking about a collection. There are many numbers. And you need to find minimum number of, let's say, 100 numbers. I'll double check if I'm not saying bullshit. Math, min. Yeah, it's just two numbers in math. You have many numbers. Oh, shit. So you would, what's binary? You mean you would get the first element. So what, you would sort the collection first and get the first element? Is your way about it? Anyway, let's look at very simple scenarios. So the first one would be a simple for loop. Yeah. So order by ascending, I'll show you. I implemented it in 3 ways, and order by ascending is actually a bad way of implementing it. So I'm very happy that you wrote that, because that's what I would also go for before I knew that it's inefficient. So the first way, of course, you could do, like, if you didn't know LINQ, you could just do, like, the first number is minimum, and then you just for each. If it's less, you take it, return minimum. Very simple, makes sense. There's no discussion around this. This is like raw implementation. It works fairly well, but that's tedious AF. And yeah, as you said, optimistic LINQ, order by and take the first element. Why would I want to order the whole collection if I only need to take the minimum? I mean, in this case, I could also just do min. That's fine. But let's say it wasn't a trivial object that I compare by itself. let's say it's a complex object that has a property based on which we do a comparison. So this doesn't work well because I first order the whole thing, and obviously order the whole thing is more complex than that. Let me ask you this. How complex is this algorithm? What's the complexity of this algorithm? The complexity through n, you know? how many? Yeah, it's just n. It's just n. The complexity is n. And yeah, and it is more difficult to read. The complexity is n. And for this one, the complexity is at least n log n, because it does the sort. There is no sort faster than n log n. Worst case scenario, this is n squared. Anyways, why would I want this complexity for n log n when I can achieve the same complexity with link-u for n? And the answer is, how do I do that? I do it through a cumulative function. So I need to use aggregate. And aggregate works this way, that if I have two elements, first and second, I can compute the third element out of those two. So if I say elements aggregate first, I can say first compared to second. If it's less than 0, I take first, else I take second. So I can do that. And this basically does the same thing that I did in here, but slightly shorter. Anyways, my point is that I have 3 different strategies of how I find minimum number. And here you can see, if I want to, apply those strategies, I just create them and use the find number. Or like I can I can inject each of those strategies somewhere, but I won't inject, like I won't depend on any of the specific strategies. I will depend on the interface, so on this thing. So that's the main thing. Do they all do the same thing? Yes, they are all finding minimum number. They just do it differently. And so in this example, you can see 1, 0, minus 6, 1, 1, and 5. If I run this example, you can see that it is all good. So that is good. They're all working fine. Actually, this one has a bug. Because there needs to be the first number as well. I think I can just write null. 0, I think I can write. I'm not sure. Yes. First with default. No, it won't work because I think this is just a placeholder for the first and second variables, so they need to be there, I think. Yeah. It needs to be recognized. There was something I could do, but I don't remember actually. But that's besides the point. We're not here to be super bug free. We're here to illustrate the point and understand the pattern. So we have two patterns. They're all working. All is good. Let me show you the point that I wanted to make with the TV remote controller. You see, these are all commands, specific ones, but they don't have to be. They can simply be I command. And I don't care what kind of command it is. Well, I care about this one. I care that it's I command with param. That's all. If, as you said, if it was any more complex, I would inject it. But always try to depend on the highest level of abstraction. In this case, if I have I command, if I can depend on I command, I will depend on I command and not on a specific one. If it doesn't change how it's used in the future. And it's not. Okay, so this is the original implementation, how it was done like 20, 30 years ago. But you know that modern implementation is actually much more driven by functional programming. So I will refactor min strategy with applying functional paradigms. How would it actually make sense in C# and not be silly dilly? So how do you think would this be implemented in C#? I would say that all of those are pretty useless, but there's one thing in particular that's very interesting to me, which is this one. Finding minimum value, like in the most optimal way possible, based on a filter I apply. So let's do a min finder. So in C#, I wouldn't write a strategy in most cases. I would just write a function or a extension method. Yep. So T, this is the syntax for extension methods. This are enumerable. And so we have many of something and we apply a filter, a predicate. No, not a predicate, but something that produces comparable. I comparable. Yeah, let's do that. Whatever. G. So this is an element and this is a type of a property that we are selecting. And so we pass T, we get G, and based on that we compare. No, I'm doing this wrong. I'm doing this totally wrong. Predicate. It's not predicate, it's a function that takes in t and returns bool. So we compare t and t, and we get a bool back, true or false, if it's bigger or not. Actually, no, we don't get that. We get int 0 or 1 or something like that. Yeah, this is good. This is perfect. Okay. Compare func. So, yeah. And the implementation of this will be the same as the other one. Many aggregate first, second, compare func, first, second, more than 0, less than 0, then it's first, otherwise it's second. Ugh. Question mark, first, second. And you'll soon understand why am I writing this crap. Functional min strategy. Demo. So now I can basically say let's take the numbers from this one. And I can say numbers min function. So I just pass a function. How do I compare the two numbers? It's not that much beautiful, but it eliminates the need of having, you see, aggregate. And it also removes the need of having this. So it eliminates a bunch of infrastructure. And if I say men, and to be honest, if I was to make a function that calculates minimum of, let's say, salary, I would also make a function like a specific extension method for just that. Let's see if it works. Run. Yeah, -6, so it's working. So yeah, I mean, very trivial. I just passed the compare function here. Actually, can I just do this? No, I cannot. Okay. Obviously, I cannot. Yeah, so there's that. Anyways, if you really want to see how, yeah, basically my point is that instead of those methods that implement an interface, I would simply have a method that, a bunch of static methods that don't implement an interface, but that conform to the same function. So let me demonstrate this in a slightly better example. Public I'm in strategies. Yes, sir. Private read only. Yes. So let's take this. Let's take that. And let's take this. Needs to be static, doesn't matter. So instead of creating all those, it makes much more sense for me to simply do a for loop. And do the same thing I did here. Get the min number, print the min number. And now I don't need those. So I basically just dropped a lot of code because I can utilize polymorphism, right? So this illustrates properly why would I want min strategy. If I run it again, you see it still does the same thing. Now, how would I achieve the same thing with this? The answer is I will simply do it through a bunch of static functions. And you might say, hey, but static is like bad. Like my senior told me that I should never write static because static is bad. Static is bad because I said so. How is that for an argument? Static is bad because I said so. Find link queue optimal. Find link queue optimistic. Static is bad because I said so. That's what sometimes my colleagues say. That something is bad because they said so. Static find min raw min link queue. No. Oh boy. Oh boy. Let's do a myth breaker test and let's compare, shall we? So let me create a main strategy classic test. Yeah, for simplicity sake, I'll just test one of those, okay? Actually, let's just name it raw. Let's test raw in each scenario, okay? Main raw test. So what? Let's create a minimalistic scenario. Happy path. Actually, let's pass in a bunch of numbers. So we have theory, we have member data, we pass in something that provides numbers, min expectation, let's say. We say public, static, enumerable, object array, min expectation. We say get, and we say object array. Object array, expectation, no numbers, well, one number. So if we have only one number, we get that number back. Yield return number one returns one. Next, we have number one first returns first smallest returns first. So if we have 1 and 2, it returns 1. Yield return first smallest. If we have first second smallest, returns second. So 2 and 1 returns 1 still. Second smallest returns second. Yield return second smallest returns second. And last one, smallest in the middle returns the middle. So if we have 2 and 1 and 2, then it returns 1. Yield return smallest in the middle. So we have all our scenarios here. Right, so find returns minimum. So what do we pass? We pass, shit, I fucked up. We pass new int array with one number. With two numbers. With two numbers. With 2, 1, 2. Okay. Cool. So int numbers, int expected min. So we say var strategy new min raw strategy find numbers var min should assert equal expected min. So how many lines are there? 3 lines of code. Let's double check if it works. Oh shit. Fuck. Hell? What the hell? Oh shit, I'm an idiot. So it needs to be maximum value. And actually, shit. It's a difficulty, a massive difficulty for generic comparison. Because I cannot compare. Fuck. Well, I can say that it's the first one. Yes, the point is that static classes are, you cannot, like, nothing is easier to test than static classes. There's nothing easier. Absolutely nothing easier than static classes testing. And let me prove that. Because right now I didn't yet. So we have min finder. Yeah, we have min raw. How do I test the other one? Min finder tests. How do I test the other one? What do I need? If I delete this, what do I need? Do I need this? Nope. What do I need? Do I need this? Nope. What do I actually need? I need min finder. And I say find draw. Mind draw, really? Mind draw. Oh boy. Yeah, you get the point. Anyways, this is literally 1 line less. This doesn't need any initialization. I literally just call it. I run it, it's the same outcome. So for, well, it's the same problem because I copy pasted. So yeah, if you look at the code of just these two, it's 2 lines versus 3, because I don't need to create anything. That's why it's easier. And in fact, testing static is the easiest. However, complexity comes when static is a dependency, but that's not an issue either. So in this example, I am a bit lost. In this example, in our demo, we created 3 strategies here, but we could have done a different thing, honestly. I mean, for this one, we need to do the same thing, right? So instead of having 3 I minimize strategies, we can simply have 3 functions. What? Functions that take integer, actually functions that take IEnumerable of int and return int. That's our contract. That's what we're testing. And there are many of those. So what's the first one? The first one is minfinder find raw. Next one, it's not int, it's t. Can I have generic functions as delegates? Shit. I obviously cannot. I actually can. I'm an idiot. Int and int. So what do? Find raw t. Fuck. Can I do that? Int. Can I do that? I cannot do that. Fuck. Is there a workaround? Is there a workaround? Okay, what if I do a little workaround? Yeah, sure. Won't really work. What if I pass it here? Public func equals funcs equals static. Yeah, that works. Okay. I think, did I just fuck up this part as well? I did. Okay. Actually, this is something I just learned, so it's good for me. I didn't know it works this way. Okay, So this is how you can do it with functions too. Man link you optimistic. Man finders. Whoops. So now I can just say whooped for each var for each, come on. We do this. We don't do that here. So we do simply main finder. Well, we pass on numbers. So boom. So my point is that just like you can inject something that's interface based, you can inject func. Function, action is the same abstraction. And my point on top of that is that really commands are very similar to actions. I literally could have done the same thing with actions here. You see? Here. In my controller, instead of my command, I could have used action and invoked those. Or instead of my strategies here, I just used a function, a func. So strategy is a lot like func, and action is a lot like a command. Because it just gets called. And function, it just gets done. And it returns a result. So, yeah. Quite an interesting observation. But anyways, my point is that you don't have to think that design patterns are uniquely for, you know, object-oriented programming. They're also for functional programming, or rather, functional programming is heavily influenced by them. So I would really like to refactor this as well in a functional way. Boom. So let me copy paste that. Commands functional. Let's change the namespaces. Also, let's update this name. So I'll let me leave the comment. So I'll just say, no, I don't need that. Static is the easiest to test. And these will actually go to... Actually, you'll be shocked right now. You'll be really shocked what I'll do right now. Actually, I'll delete everything except TV. This will be crazy what I'll do. I should have kept the controller actually. I'll get back. So we need those, but they are simply actions. And this one is also action, but that accepts int. That's all. We don't need those. Actually, we do, but we will inject them. You'll see something cool here. Action, raise volume, action, lower volume, action, toggle, action, and change channel. Look what I'll do now. Well, I'll just do the normal injection, you know. There's nothing special. But the key part is that if I go here, if I go here, TV remote builder assembler, let's say builder is fine. I'll call it that. And I'll do something like public static TV remote controller. Why are you not right? I need to change the namespace to be safe. So we have TV remote controller, and I say build. And look what I'll do. How do I build a controller? I need the TV. And what will I do? I will say new return. Well, let's just use the bullshit. New. And look what I'll do. What do I do when I raise volume? What do I do when I lower volume? What do I do when I turn off TV? What do I do when I change channel? Anything else? Huh? Toggle, change channel. Oh, commands are still left. Okay. Oh, okay, I failed. Sorry. One. Not needed. Not needed. Okay. So if we go back to remote controller, this is literally all I needed. And I'm not saying that, I'm not saying that this would be actual implementation, but I'm just saying that you can work around. For example, if I had really complex commands, like really, really complex commands. So I could still have public static, you know, raise volume. Change volume by something, you know, and takes a TV. And something happens. Let's say this is very complex. Let's say it says if TV is on, then I can only then say that TV volume is equal value, and if TV volume is more than 100, then I say TV volume is 100. Like, this is legit code. Like, it can happen to a TV. And of course, if, like, you know, if TV volume is less than 0, TV volume is 0. You know, this is legit code. Like, this is what happens. So this is not super trivial, but my point is that I can still do the same thing. I can still pass that function from really complex commands and still do all those things. I mean, I'm just injecting, not you know, not interface-based stuff, but function-based stuff. So you have the same controller, but with different things. So that's functional programming. I'm not very functional-oriented guy as well. It's fairly new to me, but I'm lucky enough to be around the right people who familiarize me from time to time with this. So it's good. So yeah, function or interface, it doesn't matter. That was my point I was trying to make. So in functional programming, simply a command or an interface, a command or a strategy could mean a function or an action. That's all. So yeah, I hope this was useful. I will commit my code and share you the link. Examples of strategy and command. OP versus functional. FP. Gosh. There is no homework yet, by the way, for this topic, but I'll try to come up with something tomorrow, and I'll try to also catch up with the solid homework because I was slacking off a bit. Here is the link to code, and here is the link to slides. So yeah, that is all I have for today. Thank you all for watching, and see you probably on Saturday. I'll try my best to stream at that time. Bye. You're welcome. Bye. Good night.